Hey, ladies and gentlemen, and welcome to Unit 9, Note 6-1. So this is actually our third to last notes video. You have 3 notes videos this week, and then we're done. And then we're going to start reviewing for the finals. So we're almost there. You guys can do it. What we're going to start with is we're going to start by doing actually a review of long division. So this is something you learned back in elementary school when you had to divide without using a calculator. So what you do is on the outside, you're going to put 15. Then under the inside, this 15 is called the divisor. Then underneath is called the dividend. So that's what we're going to be dividing. Okay, so we have the divisor and the dividend. So what we want to do is we want to think of, it's kind of like what can multiply to what. So we're going to start by looking at 15. So what times 15 is going to get us near 3? Well, that's never going to happen. So then we're going to look at actually these two together. So what times 15 is going to get us close to 32? Well, 15 times 2 is going to give us 30. So what I want to do is I want to multiply 15 times 2. So now I'm going to take 15 times 2, and that's going to give us 30. And now we're actually going to be subtracting those. So we're taking 32 minus 30, and when we subtract those, we get 2. And now I'm going to bring down just that 4. So now I'm asking myself, how many times can 15 go into 24? Well, 15 can only go into 24 one time. So now I'm taking 15 times 1, and that's just going to give me 15. Again, I'm going to subtract those. So 24 minus 15 is going to give me 9. So now I'm going to bring that 0 on down. So I'm asking myself, how many times can 15 go into 9? So sometimes I start, or 90, sorry. Sometimes I just start by dividing. So 90 divided by 15 is actually 6. So 15 goes into 90 6 times. So I take 15 times 6, and we're going to subtract those, and we get a remainder of 0, which is good. So that means that our answer to this one is 216. Let's take a look at number 2. So for number 2, we're taking 12 and we're dividing 5,730. Well, 12 is never going to go into 5, so we want to figure out how many times 12 can go into 57. So I'm thinking 12 times 2 is 24, times 3 is 36, times 4 is 48, and then times 5 is going to be all the way up to 60. So that's not going to quite fit into 57. So 12 can go into 57 4 times. And if you're not sure, you can take 57 divided by 12 and see what it equals. Even if it's not a whole number, you can take what number you have. Like when you do that, you get 4.75. And so you know that at most it can fit 4 whole 12s in there. So then we're going to take 12 times 4, and that's going to give us 48. So then we're going to subtract 57 minus 48, and that's going to give us 9. Now we're going to go ahead and bring the 3 down. So I'm going to take 93 divided by 12, and I see that I can fit 7 whole 12s into 93. So now I'm going to take and I'm going to multiply 12 times 7, and that's going to give me 84. So I'm going to subtract that off. 93 minus 84 is going to give me a 9. And I'm going to bring down that 0. So now I want to see how many times 12 can go into 90. So 90 divided by 12, that's going to give me 7 again. So I'm taking 12 times 7, and that's going to give me 84 again. So now I'm going to subtract those off, and I'm left with 9. Well, I don't have any other numbers that I can bring down. So I have a remainder. So what I'm going to do is I'm going to write out my answer from up top, which is right here. So I'm going to write that answer out first, 477. And then now I'm going to add my remainder. I'm going to take what number is left over here, and then I'm going to divide it by my divisor, which is 12. So I get 477 plus 9 over 12. Now if you want to reduce that fraction, you can, but you don't have to. Okay? Next, let's take a look at number 3. So first thing I want to do is set up my long division. So I'm dividing 9 divided by 864. So again, I don't want decimals on these. I want you to go through and actually use long division. Well, 9 is never going to go into 8, so we have to look at it as going into 86. So 86 divided by 9, I get a huge decimal, but I know I can fit 9 9s in there. So 9 times 9 is going to give me 81. So then I'm going to subtract those off. 86 divided by 81 is going to be 5. Then I'm going to bring that 4 on down. So now I want to figure out how many times 9 can go into 54. And it can go into it 6 times. So 9 times 6 is 54. Subtract those, and then we get a remainder 0. So then our final answer is 96. Okay, so we didn't have a remainder on that one because our remainder was 0. Let's take a look at number 4. So for number 4, we're doing 6, and we're dividing 528. Well, 6 is never going to go into 5, so we want to see how many times 6 is going to go into 52. And 6 is going to go into 52 8 times. Okay, so then we're going to take 6 times 8, and we get 48. So we're going to subtract those two, and we get 4. So I'm going to bring down another 8. So I want to figure out how many times that 6 can go into 48. If you're not sure, take 48 divided by 6 and see what's the whole number that you get. So 48 divided by 6 is going to be 8. So now we're going to take 6 times 8, and we get 48. Subtract those, and you get 0. So again, we have a remainder of 0, and our final answer then is 88. Okay? Let's keep going. So now we want to do this doing long division. So we have 5, and we're dividing 370. So we want to figure out how many times 5 can fit into 37. So when I do that, I can divide 37 divided by 5, and I end up with 7.4. Well, I'm not going to worry about 0.4. I know that I can get 7 whole 5s in 37. So I'm going to do 5 times 7, and that gives me 35. So I'm going to subtract those, and I get 2. And then I'm going to bring that 0 on down. So I want to see how many times 5 can go into 20. And that's going to be 4 times. 5 times 4 is going to be 20. So we're going to subtract those, and then we get a remainder of 0. So our answer for this one is 74 because we don't have a remainder. Let's take a look at number 6. So we want to take 7, and we're going to divide 672. Well, 7 isn't going to go into 6, so we have to see how many times we can get 7 into 67. So I just divide 67 divided by 7, and I get about 9.57. I'm not going to worry about the 0.57. I know that I can get 9 whole 7s in 67. So then I'm going to do 7 times 9, and that's going to give me 63. So now I'm going to subtract those two, and I'm left with 4. Now I'm going to bring on down that 2. And I want to see how many times 7 can go into 42. So then I can go ahead and divide it if I'm confused. So 42 divided by 7, and I get 6 whole times. So I'm going to take 7 times 6, which is actually also going to give me 42. So you subtract those, and you get a remainder of 0. So your final answer for this one then is 96. Next, now we're going to do some dividing with some of these polynomials. So this is just kind of getting into what we're doing tomorrow. So here's what I want you to do to actually make these problems easier. I want you to look at it as 3 separate problems. So I'm going to look at it as this as a fraction, as this as a fraction, and as this as a fraction. So I'm going to do 12 a to the 5th divided by 6a minus, I think that's a minus. Let's check here. Yep. So then minus 3a squared divided by 6a plus 42a over a. So now we're just dividing each of those separately. So I'm going to start by looking at my first fraction here. First thing I want to do is reduce that fraction. 12 divided by 6 is going to give me 2. And then I have 5 a's on top and 1a on the bottom. Next, over here, negative 3 divided by 6, well, that's going to reduce to 1/2. And I have 2 a's on top and 1 a on the bottom. I'm going to cancel those out in a second. Here I have 42 over 6. This should be 6a. 42 divided by 6 is 7. Then I have an a over an a. So now I want to cancel out my overlapping a's. So those are going to cancel, those are going to cancel, and those are going to cancel. So in my first term over here, I have a 2, and then I have 1, 2, 3, 4 a's, so that's going to become a to the 4th. Minus, I have 1a on top over here, and then a 2 on the bottom here. These a's canceled out, so now I'm just left with 7. So that's your fully simplified form. So all I did was break it down one term at a time. And don't worry, because we're going to go through a lot more examples of this. So let's take a look at this next one. So again, you want to split up each term individually. So I'm going to take 15x to the fourth and divide it by 5x. Then I'm going to take 35x cubed and divide it by 5x. And then I'm going to take 20x and I'm going to divide it by 5x. So now I want to go through and simplify each individual fraction. So 15 divided by 5 is going to give me 3, and then I have 4 x's on top and 1 x on the bottom. 35 divided by 5 is going to give me 7, 3 x's on top and 1 x on the bottom. Well, 20 divided by 5 is going to give me 4, and then I have an x over an x. So now I want to simplify some of those x's. So I can cross off this x with this x, this with this, and this with this. So with this one, I have a 3 left over, and then I have 1, 2, 3 x's. So I'm going to write this as x to the third, minus, I have a 7, and then I have 1, 2 x's is x squared, and then we want to add 4 at the end, so I have x to the fourth. So that right there is your final answer. All right, let's take a look at numbers 9 and number 10. So this is going to be a lot of the same thing. So I'm going to split up those fractions like that. So I have 4c cubed over c plus 2c squared over c minus 8c over c. So I don't have any fractions that I have to reduce. So I just have to worry about my c's. So here I have 4, and then I have 3 c's divided by c. Here I have 2, and then I have 2 c's divided by c. Then I have c over c. So now we want to cancel out our overlapping factors. So I can cancel this out, cancel this out, cancel this out. So here I have 4c squared plus 2c minus 8 when you cancel all of those out. And that right there is your final answer. Next, let's go ahead and take a look at number 10. So number 10, I'm going to split it up. So I have 16 r to the fourth over r squared. So all I'm doing is that dividing up that divisor by each term separately. Okay, so I've written all of that out, and now I want to go through and simplify. There's no fractions I have to reduce, so I'm going to go straight to my r. So I have r divided by r. If you know how to do this with rules of exponents, please feel free to go ahead and do that. For some of you, it might be still kind of tricky, so if you need to write out the r's, go ahead. So now let's cross off our overlapping r's. Those cancel, those cancel, those cancel, those cancel, those cancel, those cancel. So for this one, we have 16, and then I have 2 r's left over, so that's going to give me r squared, minus 4r plus 2. So that right there is your simplified version. Let's take a look at the last two. So again, we want to split those up into 3 fractions. So we have 9z to the 7th over 3z to the 4th minus 27z to the 6th divided by 3z to the 4th minus 30z to the 5th divided by 3z to the 4th. So let's go ahead and let's reduce that. So we can reduce the fraction 9 over 3 to 3, and then I have 7 z's divided by 4 z's. 4 z's, that sounds funny. Okay, so 27 divided by 3 is 9, and then I have 6 z's on top divided by 4 z's on the bottom. Next, 30 divided by 3, that's going to reduce to 10, and then I have 5 z's on top and 4 z's on the bottom. So let's go ahead and cancel out some of those z's. So this cancels. So then on this one, I'm left with 3z cubed. This cancels. And then I'm left with 9z squared. And then here, those all cancel, and I'm just left with 10z. So let's go ahead and get you started on that last one. I'll probably have you finish up most of it on your own. So let's just get it all split up, and then I'm going to have you finish it on your own. So you're going to write it out as 4x to the 6th divided by 2x cubed minus 2x to the 5th divided by 2x cubed, should be a minus, plus 6x to the 4th divided by 2x cubed. So go ahead and finish this one on your own. Bring up your completed note sheet when you're done, and I'd be happy to give you the homework. Thanks for listening.